Coming to the row cipher. See, row is nothing but whatever the plain text which I have, that plain text I will be rearranging with respect to the column number. Okay, column number. So if my data is of size 15, if my data is of size 15, let me say, if my data is of size 15. So how can I be knowing this many rows I should take? See, key is fixed. See, can you see? Key is fixed. So when the key is fixed with n number of integers, see how many integers are there? 1, 2, 3, 4, 5, 6, 7. So here I am fixed with 7 columns. Don't forget, here after seeing the key, I'll be fixed with 7 columns. Clear? Now, if I have my elements as 34, let me say 34 elements are there. Right. So if my elements are 34, if my row column size is 7, how many rows I should take? How many rows I should take? So this is dependent on, see, so 34 by 7 is nothing but approximately 5. But I'm missing with one letter, right? So I'll be adding that one letter here. Okay. After adding one letter, 7 means I should go with 5 rows. Okay, 5 rows and 7 columns is fixed after seeing the key. Right. Now, in our example, whatever we have given here, just to see what is my plain text is, whatever the plain text which I have, first of all, I'll be writing in 7 formats. 7 formats. See, 1, 2, 3, 4, 5, 6, 7, right? So whatever the plain text, this is a plain text. So let us write our plain text first. Attack, post, pwned, until 2 AM. So this is my plain text. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 are there. Right. See, 25 are there. 25 will be placed in 7 column manner. See how to place this? So take, as we are fixed with the number of columns. So let us write first A, T, T, A, C, K, P. Okay. Till here we have fixed with the first row. How can we understand that is the first row? Because here we have 7 columns, right? So after filling the 7th column, automatically it should enter into the next row. So from there, POST, PONE, 7th means 14th letter completed. Come down. Okay. D until 2. See, at T, we have completed with the 21st letter. Come down. Now, this is 22nd, 23rd, 24th, 25. Now, what about the remaining elements which I have empty slots? Before filling the 28th position itself, at 25th, I have completed with my plain text, right? So to fill this gap, we should place some extra elements. See, we call these extra elements as dummy elements or added elements or padding elements. We can call any one of the terminology. Extra element, padding element or added element. See, you can add X, Y, Z or else you can take any other alphabet if you want to just add. Right? So add this, then. What is the key given now? 3, right? So first write 3 column. See, TTNA. TTNA. Clear, right? Next, 4th, APTM. See, APTM. Next, 2, TSUO. TSUO. Next, 1, AODW. So, like this, you just frame each and every column given in the key order. Right? So column order, see, reorder with the columns accordingly with the cipher text. So cipher text is ready, right? Now this ciphertext will be sent to the receiver. Now at the receiver end, how the process will be taking place? Yes, right? See, after you have this key in your hand, see, even the receiver should have this key in his hands, right? So now key will be along with the key. See, whatever the elements he has, 7 key size. See. Now, whatever the element structure in the ciphertext, he will just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, right? So 28 alphabets are there, and along with the key size, it is 7. So every element will be, every column must have 4 alphabets. So this is fixed, right? Every column must have 4 elements. Now he will be starting framing with the construction of the plain text back. Now 4 size, right? So TT, he will be writing TTNA. Clear? So at what position it should have? 3. Now APTM should be at 4th position. See, after this, you just have this structure first, 5, 6, and 7. Now 3 is filled, right? Now go with 4. So APTM. APTM. Next structure is 2. So next is TSUO. In the 2, TSUO. Next, AODW in the first place. AODW. Next, so like this at the 5th position, next elements are COIX. Next, KNLY. Okay. Next, PETZ. So these are the row table. Now he will be started writing from left to right, top to bottom, so that his plain text will be back. See, first write row 1, row 0th row, that is attack. Next P. Next, move to the next row, postponed. This one until T. 2WAM and XYZ. See, after having the proper structure in his hands, the XYZ may be added data. He will feel that they added data and he will remove that, and the plain text will be with his hands. Okay. So this is called row cipher. And the next one is a root cipher. See, root cipher is very, very simple. We can go with either diagonal structure or spiral, or else orthogonal or crab. So we will be having n number of roots. This will be in the square matrix only. Okay. Maximum we will go with the square matrix depending on the size of your string. If the size of the string is 34, let me say if the size of the string is 34. So what may be the nearest larger a square matrix? 6 by 6 means 36, right? So we will take 36. If the given string is 34, we will take extra padding elements XY and we will be adding with those 2 things to this. And so we will make that 36 and we will arrange with 6 by 6 ordered matrix with the rows and columns. See, after having all this in our hands, we will started moving along with the given structure. So if we are going with this diagonal format, see diagonal format this way, attack, ATTACK, attack. Okay, done. Sorry, one second. This is not orthogonal thing, just a diagonal. See, first write this one. Next, ATTACK, this one. Attack, POST, post, PONED, postponed, until the NEXT means next, CALL, call, next call, BCOLL, cool, be cool. So extra padded elements are Y and Z. attack postpone until next call, be cool. So this is a plain text. Okay, so this plain text we will be writing in this diagonal formats, and then from top to bottom, left to right, we will generate the ciphertext. ATAPPU, see this is ATAPPUT. So this is a ciphertext generated. Clear with this, right? Now, at the receiver end, what happens? See, at receiver end, nothing is there. As this is having how many elements? See, can you see? Oh, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3. So this is having 36 size, right? So 36 means what may be the square matrix? 6 by 6. So he will be starting writing at the receiver end. He will be started writing with 6 letters in one column, I mean row format. So if we start writing ATAPPU, ATAPPU will be first row. So like that, he will fill all the rows and columns. Now after filling, as we are going to say as a one hint of key that this is diagonal or this is spiral. Spiral is nothing but in this manner we will be writing the elements. See, in this manner, like this. Okay. So ATAPU. So spiral will be in this format. So like this, you will be having n number of formats. Diagonal is a simpler one. Now after writing this, as this is the diagonal, he will be taking back his plain text. See, first he'll write A, next TTA, ACK, postponed. So like this, he will be getting his plain text back. So I hope everyone is clear with the content, right? Now, after knowing the transposition and the substitution ciphers, there is another cipher called product cipher, where we are going to utilize both substitutions and also the transpositions. So this is a basic bridge for the modern ciphers, whatever we are following nowadays. See, instead of utilizing only substitution or else only transposition, which are not giving much security, so what developers has decided is for the successful journey of security. So they have decided we will be utilizing substitutions sometimes, and we will apply same on the same text. We'll apply some transpositions and then the substitutions, and we will make our secret code more stronger. So for that reasons, the modern ciphers has been included with both substitutions and also transpositions. So in transpositions, technically we call permutations. So S and P are very, very important for the modern ciphers. See, two substitutions make more complex substitution, two transpositions make more complex, but substitution followed by transpositions makes much harder cipher. So that is the reason we are going to include both together and we form as a product cipher. Okay, this is very, very important 2 marks question in your exam point of view. So if you have any queries, just meet me in a personal channel or else just comment in the comment section. Thank you for listening.